Okay, this is sample problem 18.2. From the standard entropy values in Appendix 2, calculate the standard entropy changes for the following reactions at 25 degrees Celsius. Okay, so we're going to use the standard entropy values, and the equation that we're going to use for this calculation is that delta S under standard conditions for a given reaction is equal to the sum. So we're going to add up the number of moles of a particular product times the standard entropy value from the appendix of that product minus the sum of the number of moles of a given product, reactant times the standard entropy of that reactant. Okay, so we look those values up. The number of moles of the product or the reactant are the coefficients in the balanced equation. So let's take a look at A. A is the reaction CaCO3, solid, goes to CaO solid, plus CO2 gas. So we look up the entropy values for each of these substances. For calcium carbonate in the solid phase, it's 92.9. And that's joules per Kelvin mole. For calcium oxide, it's 39.8 joules per kmol. And for carbon dioxide, it's 213.6. Generally, what's observed is that gases have significantly larger entropy values, standard entropy values, than solids do. So if you take a look at the CO2, it's quite a bit larger than CaCO3 or CaO. Okay? Now for this reaction, the balanced equation, all the coefficients are ones. So that makes this calculation rather routine. So delta S of the reaction, there's two products. There's calcium oxide, so that's 1 times 39.8. I'm going to go ahead and leave the units for the end. Plus, so we're adding up. In fact, I'll put this in brackets just so you can see. We're going to add up all the products. So for carbon dioxide, 1 times 213.6. So that's summing up all of the products and then subtracting from that the reactants. There's only one reactant in this case, and that's the calcium carbonate. Okay. So products minus reactants. So that's 39.8 plus 213.6. So 39.8 plus 213.6. And then we're going to subtract from that 92.9. And you get 160.5. Okay? The units are joules per kmol. So it's a positive value that tells us the entropy increases during this process. This is an increase in entropy. Okay? Let's try part B. So part B says nitrogen gas plus 3 hydrogen, 3 moles of hydrogen gives us 2 moles of NH3. Okay, so we go to the appendices for this one. So for N2, it's 191.5. That's the standard entropy value for N2 at 298 Kelvin. And 131.0 for hydrogen. For ammonia, it's 193.0. Okay. So now we can run it through the equation. So we're going to sum up the products. There's only one product. Oops, sorry, I got the wrong coefficient. It's 2 times 193, right? 0.0, because there's 2 moles of ammonia. Now let's subtract from that the sum of the reactants. For nitrogen, it's a 1, and for hydrogen, it's a 3. So 1 times 191.5 plus 3 times 131.0. Okay. So 2 times 193, $386. And then we're going to take 191.5. So 1 times 191.5 plus 3 times, oops, sorry about that, 3 times 131. 584.5. Okay, so 386 minus 584.5. Minus 198.5. Again, the units are joules per kmol. So there's our answer for part B. Notice how it's negative? It's negative because we took really 4 moles of gases and combined it into 2 moles of gases. So what happens is, in this process, you're taking 4 moles of gases and then essentially condensing them into half as much in terms of the amount of gas. So that's a decrease in entropy, as we would expect. Okay? The last one is hydrogen plus chlorine to form hydrogen chloride. So let's do this one here. So H2 plus Cl2 goes to 2HCl gas. Okay? Now if you think about it, we already did hydrogen. Hydrogen was 131.0, but we need to look up the chlorine and we need to look up the hydrogen chloride. So the chlorine is 223.0, and then the hydrogen chloride is 187. Again, those come from Appendix 2. So delta S of the reaction. Sum of the products. Well, there's only one product, but there's 2 moles of it. So 2 times 187.0 minus the sum of the reactants. First reactant is H2, 1 times 131.0 plus 1 times 223.0. Okay. 2 times 187, 131, 223. So 2 times 187, okay, minus, now let me put this in parentheses, 131 and 223. End of parentheses, and then get there. Looks like it's just 20. Positive 20. Not very big, right? So our answer is plus 20 joules per kmol. So a slight increase, right? A little more disorder, a little more entropy in this process. The combination of that entropy forming 2 moles of that, not a big difference. It's a pretty small difference in entropy, but it is a little bit positive. Okay.